Well, the question today is on probability and statistics 1, that is Cambridge International Examinations, advanced subsidiary and advanced level. The paper's code is 9709, as you can see, and it was taken in February-March of 2016. So the paper of concern here is question 7, which reads, the times taken by a garage to fit a tow bar onto a car have a normal distribution with mean m hours and standard deviation 0.3 hours. It is found that 95% of times taken are longer than 0.9 hours. Roman 1, find the value of m, where m is the mean. Roman 2, on one day 4 cars have a tow bar fitted. Find the probability that none of them takes more than 2 hours to fit. 5 marks. Then, the times in hours taken by another garage to fit a tow bar onto a car have the distribution that is normally distributed with the mean of u and a variance of that, where u, which is the mean, is given as 3 standard deviations. Roman 3, find the probability that it takes more than 0.6 hours to fit a tow bar onto a randomly chosen car at this garage. 3 marks. So the solution to this question is as follows. Well, we are given that mean is equal to m hours. It's in hours. We are also given that standard deviation is 0.35 hours. It is found that 95% of times taken are longer than 0.9 hours. Find the value of m, Roman 1. So we know that z is equal to x minus mu over that, which is the standard deviation. Our x is 0.9 minus m all over 0.35. That's what should describe z. But we can read the value of z from our standard normal tables by using the probability of 95. So we do that by looking at the table as, from the standard normal tables, we check within the body because 95% corresponds to a probability. And so we look for 95 within the body. 95, 95, 95. We find 95 somewhere, 95. Now this is 95, it's gone beyond, but this is close to. So we find a value here to add so that this is 0.95. So already we have 0 point. This we see that that is 0. This is 0.9495 at 1.64. So what do we add? What do we add to this for it to become 0.95? So we come here and see that it needs 5 to get there. So we see 5, we get 5 here. And 5 is under 5, column 5. So that is 1.645. And the z value that we want is 1.645. And then we see that we get that the z value that corresponds to that, it's either positive or negative 1.645. So for us to end up with time which is not a minus, we'll be having minus 1.645 is equal to 0.9 minus m all over 0.35. That means that 0.9 minus m is equal to 0.35 times minus 1.645. If you work it out, that should imply that m is equal to, if you work this out, that is if you make M the subject, you are supposed to get the M value as 1.48. As 1.48. I think making it the subject simply means you would have to bring 0. Okay, having multiplied 0.35 by this, then you subtract 9 the other end. The resulting value is going to be a negative this end, and this also negative end. So minus 1 divided by minus 1, we end up with this. Okay, Roman 2. So the answer is this. That's the answer. Then Roman 2. Roman 2 says that on one day, 4 cars have a tow bar fitted. Find the probability that none of them takes more than 2 hours to fit. None of them takes more than 2 hours to fit. So I would say probability that x, if x is time, is less than 2. This will be equivalent to probability that z is less than 2 minus 1.48 that we have, which is the mean, divided by 0.35, like that. And this would imply that probability that z is less than, if you work out this part, 2 minus 1.548 divided by 0.34, you should be able to get 1.50. 1.50. So we are working with 1.50 probability that z is less than 1.50. So we can read the corresponding probability. When z is less than 1.50, the corresponding probability we read from the tables as. Now, here we want a z value which is less than 1.5. Now z is here, 1.5, we come 1.5 is here, and we get that value to be 0.9332. And we see that this probability is given by 0.933, as you have seen, 933. Therefore, to get our required probability, we are going to raise this to power 4, which is 0.933 raised to power 4. And that gives us 0.758. So you need to confirm that using calculators. And that's the answer to that particular part. That's Roman 2. Then Roman 3, we are asked, find the probability that it takes more than 0.6 hours to fit a tow bar onto a randomly chosen car at this garage. All right. So probability, we were told that the times in hours taken by another garage to fit a tow bar onto a car have the distribution this. So it's they have the distribution n into this. That means a normal. Whenever we have this, it simply means a normal distribution with a mean of mu and a variance of that. Where we are given that mu, which is the mean, is 3 standard deviations. 3 standard deviations. So we say probability, we call that time t to make a difference. We are calling that x. I want to refer to this as t. So t, probability that t is greater, takes more than here. T is greater than 0.6 u will be given by probability that z is greater than 0.6 u minus our mean. We are given our mean to be, we are told that where u, just write it as u because it's the mean, that's the mean, over standard deviation. But we are told that standard deviation is, we are told that mu is equal to, actually we are told that mu, which is u, U is equal to 3 standard deviations. That should imply that our standard deviation is U over 3. So I bring U over 3 like that. I bring U over 3 like that. U over 3 like that. So let me U over 3 like that. Then I need to simplify. That should then bring me probability that Z is greater than. Z is greater than. This should give me, let's see what we have here. That should be minus 0.4U divided by, actually times 3 over U, times 3 over U. So this goes with this. And we end up with negative 1.2. So we say this is 1.2, negative 1.2, like that. So we check from the tables, the probability that corresponds to 1.2 as, check as. Yeah, if we want a probability that corresponds to a Z value of 1.2, we come under the table, the normal distribution function, and then we check Z column 1.2, we find here that corresponds to 0.8849. So 0.8849 is that is the value that we want. It's the value that we pick and proceed with our question. And we see that it is 0.885. That's the answer. So that wraps up our question. Kindly like, subscribe, and comment.